going to stay with the theme of sustainability for a little bit. And the next presentation, the next theme in the Big Idea Challenge is led by Professor David Ebert, who is the Silicon Valley Professor of Electrical and Computer Engineering here in the College of Engineering. However, David is a Renaissance man. He's somebody who, he's an electrical and computer engineer, but he's also working on sustainability, agriculture, data, technology, and how that all comes together, how that all converges to create more sustainable practices for food security and agricultural production. So, David? Oh, yeah, here's a clicker for you.
Well, I guess you could also say I enjoy meeting a lot of people who just aren't computer scientists. So I like the diversity of the colleagues and problems. So I'm always someone who enjoys finding what the challenges are in all these fields and figuring out how we can help people. And we've been very fortunate here to work on this problem at a different scale than what Tom was talking about. When I talk about local solutions, I'm talking about a block within a field. When I talk about larger scale solutions, I'm talking about regions and states and entire states. So again, as in most things, it's a multi-scale problem, and it's also a way that you need to work in a systems of systems to come up with a solution that will solve this. And so we've been focusing on how technology can be harnessed and data fused together to help achieve sustainability and resilience in agricultural communities. And to give you an idea of the problem, let's look at California, and where they've had a series of year after year of droughts that have had a dramatic impact on their agriculture. Their aquifers are so depleted that many of the homes no longer have running water in those homes. And the variability of the weather is just so dramatic that you can't decide what you're going to do this year, because you can have a 5 times difference in the amount of precipitation you get and when you get it. So this all leads to very challenging problems for growers to try to optimize what they're doing. You may say the problem in California is now solved. You've seen all the pictures of the record rains, the mudslides, record snowstorms that just have occurred in the past week in California. So is this dry period, as some people like to say, it was just cyclical and it won't happen again for a long time, gone? But the answer is no, it's not. Sorry, this is an older version of my presentation. I had a better image there, so if you look at 2018 versus 2019, 2019 actually has worse drought conditions this January than California experienced last year. And so this is a problem. This is not a problem that's going to be going away. So there is no clear solution to this. This is not just a problem, though, in the US. It's also a problem around the world, because you have the fact that glaciers are rapidly receding. You have areas in the world, such as Arequipa, Peru, where they've taken high deserts and used glacial runoff to irrigate them, to turn them into productive farmland. So you've got these over 200,000 hectares of farmland that are that are using the meltwater and the snowcap runoff to irrigate these fields. So the question is, as you have this very precise resources, how can people optimize this? And is this really an indication of what may be occurring in the future for other regions of the world? And how do you adapt and maintain sustainability? This is a key component that we've been trying to address. And to do that, what we've really focused on is how do you balance the food production, the energy, and the water, as Tom has already talked about. And we've really focused in on looking at perennial agriculture, because it's a large part of the US agricultural economy, especially in the Western US, and it's a very difficult decision-making environment, because people plant their crop for 10 years, 20 years, 30 years. So every decision you make just doesn't impact what you're doing this year, and next year you just plow everything under and start again. It has a long-term impact. So it becomes even a more complicated decision-making environment. And in deciding the sustainability, we need to make sure that we're not just talking about sustainability in terms of the environment, but we also are looking at the economics and the community impact of those sustainability decisions. And if you talk to most growers, they're very concerned about ecological sustainability, but their number one priority is economic sustainability. So you really need a situation that will allow you to address all of these. The good thing is, though, there's the potential for great solutions with all the data and sensing that's available today through precision ag that offers the promise to improve efficiency of irrigation, only irrigate where you need it, increase yield, increase the supply chain. You also find that there's all kind of new sensing technology that's coming out, aerial drones, remote control objects that you can put out there. You've got sensors such as was just manufactured this morning in the Burke Center, a nitrate center that's extremely low cost and can be planted. And you could think of doing this so that you can get real-time nitrate reading throughout the growing season to decide how much nitrate you really need to keep the level you're interested in instead of having the runoff problem we just talked about, right? So there is emerging ways to get this data in. And the big problem, though, is that every grower I've talked to, and we focused a lot on perennial crops, but it's the same thing that with other projects when we're talking to agricultural seed producers, all the farmers who deal with row crops face the same thing. All this data comes in and they've got to figure out what do they do with it, right? I know so many producers who have told me they've stopped using new sensing technology and new software packages because they spend more time trying to transform the data into something to help them make a decision than the value they get out of it. And so that's a real big problem. Now, there are companies that say the problem has been solved. With the evolution of deep learning technology, you just put all of that in with your training data and it will give you the answer and tell you what to do. However, the problem with that is in agriculture and a lot of life events, you don't have training data of what's going to be happening over the next 6 months. Especially if you look with data we've been collecting, no growing season has been the same in the past 15 years. So your training data can only work deep learning only works if you have good priors for the training. So you've got these environments where not all of the data needed to make a decision fits in, first of all, and you don't have repeatable circumstances, so deep learning alone is not the solution to this. You need a way to be able to go ahead, bring the human expertise in there, and have these algorithms adapt and learn with the human to solve the new problems, as well as bringing in predictive models into what's going on based on science. And so you can get all of this new technology that's out there. You can have all of these companies that are doing data analytics and allowing precision ag solutions. But the problem that most growers face, as well as policymakers face, is they all come and say, this is what should be done to solve your problem. And what a grower really wants to know is what is the best solution for the problem I'm facing in the short term and the long term? How do I not only navigate that sea of data, but the sea of solutions that everyone's portending to be the solution to the future? So we've really focused on how do we enable sustainable decision making for the local producer, for regions and resource control districts, as well as for policy making to make sure that we're getting the best decisions that allow for sustainability and resiliency. And the approach we've taken is to start by integrating novel technology. Take and look at what technology is available, look at the new emerging technology, the new advances in science in terms of models that are adaptive, new approaches for doing soil modeling, new approaches for understanding mixed canopy systems in perennial crops. Bring all of this together with the advances in predictive analytics, human-guided machine learning, explainable AI, into the approach of creating a collaborative human-computer decision-making systems of systems. And that's what our project has been focusing on. We see this as an approach from the feedback we've gotten that's very effective and everyone seems to think makes a lot of sense. There's people who just do sensor-based systems. There's people who run models and the model's good enough. You never need any data to validate it. We bring all of that gap back into a feedback loop, so we have data-driven models with innovative science solutions that feed into them, new models for climatology and prediction of environmental conditions, and human-in-the-loop guidance to bring that expertise in there so that you have informed decisions and policies that can generate from it. And by doing this, as Tomas started off talking about, this is definitely very transdisciplinary. We brought a wide range of expertise together, from energy systems people to policy and economics to looking at perennial crop production, viticulture, enology expertise, soil science with new ways of understanding soil functionality, environmental engineering brought together to bring in that remote sensing data, image analytics that come into play, and pull all of this together with a key component being our industry partners so that we understand what people need. And that's what really we have focused on, is identifying what are the opportunities and what are the challenges from the local to the regional level. By running a series of workshops, having small to large scale producers, having community associations, resource control districts, and grower associations get together and discuss what are the challenges and opportunities that they face. And so we've been very fortunate to form a stakeholder board of a lot of these perennial crop production associations. We have a lot of regional groups that are focused on sustainability, as well as a number of West Coast universities involved, and a lot of small to large scale producers going from a few person operation up to very large international corporations, so that we understand and will create solutions that scale from what am I going to do in this block, in this given field, to what do I do across an entire region or across all of the properties that I source from across the world. And so this is what we've really been focusing on, and these workshops has helped us create this roadmap of opportunities and things that we're starting to tackle to address. And the first thing that came out was the fact that evolving water and energy use policies need to be adapted to local and regional concerns and the environment in that area. They need to be science-based, and they need to bring together all of the perspectives, which you would expect, but policies aren't normally derived that way, from all of the stakeholders in the community. It's key to bring all of that together. The other thing that everyone said is their biggest impediment to adopt new technology is understanding the return on investment. If I spend $10,000 to instrument this field with new sensors to optimize my irrigation, what is that going to do? When will I get the payoff? What's it going to do to me economically? What's it going to do with the restrictions of water I have? And what's it going to do to my crop? In these multi-year decision-making environments, the growers don't tend to have an economics degree, and this is very hard things to understand. And you need to bring in advanced economic models that are related. They also need to deal with the labor shortage. Mechanization may offer the idea of reducing labor, since there's a huge farm labor shortage in the Western US, but if it changes the skill set that you need to be skilled workers in agriculture, it's even a greater shortage. So if I adopt this, am I going to reduce 10 day laborers and need 2 skilled people that I can't find? So these are all the things that you need to bring into that. And also, it's a huge importance to understand what is going to happen to the final product that I do. Quality and yield are both factors in perennial crops. And if you make a decision, one company's data analytics, they tout reduced water use in a given operation by 20%. They needed to pull out the crop the following year and replant it. In their success story, they never mentioned that. They say how their technology was great in reducing water usage, but for that grower, that was a huge economic loss. So you need to bring all of these factors together and balance them. And you need to help people understand what is the benefit in reality and the expectations for these new technologies. And can we come up with a way of trusting what the measure that we're getting from these? Can we come up with standards and benchmarks? Because everyone is saying that they're going to solve your problem. But what do we know as a good source of reference for this? Grower associations, universities can create those benchmarks, and those are great opportunities. And then, what you hear time and time again is no one wants to be told what to do. They don't want you coming and academic researcher coming and saying this will solve your problem, or a Silicon Valley startup. They feel that their experiences and expertise need to be developed into a solution to really solve their problem, as well as what you give them needs to be able to take advantage of the human in the loop. So there is a clear need to have human in the loop technology to solve these challenges people are facing. And that's why we've created this human-computer collaborative decision-making environment. Here's the extended team of schools we have working on this and all the different expertise that we've brought together. And in doing this, we have very simple interfaces where you can simply draw out your region on the map, get a very high resolution understanding of the soil, see alternative strategies and the payoff for it. You can look not only at a single year, but you can look at multi-year impact, both in water use and the economics of making these decisions. And we really are creating this environment where you can look at all of the different dimensions, see all of the different choices you're looking at, and have an interactive analysis session to make the most sustainable decision for those growers. And so the output of what we're doing is to really enable ecologically and economically sustainable agricultural production, more resilient agricultural communities, as well as enabling science-based and data-driven policy and decision-making within this industry. And with that, I'm happy to take any questions.
Great, thank you, David. Amazing amount of progress in just 18 or 20 months. Really great to see. I'm sure there are questions from the audience, but before we go there, I'd like to ask you, you mentioned Arequipa, Peru, in passing. Could you talk a little bit about how you're bringing these technologies there, what you're doing there, and how this might impact?
Actually, as we started the project and we were forming the team together, there was this opportunity to work with the University Nacional San Agustin with this Peru Nexus project, that Arequipa Nexus project we have going on. One of the things that this university has been doing in the first visit there that Tim Philly and Tomas had is they have a vineyard. And they're dealing with polluted, irrigated water coming in. They've got salt problems, et cetera. It is in this area where they're using the glacial runoff water. And the question is, how can they optimize what they're doing? They've had really bad problems in production quality, as well as sustainability of those operations. And so we were able to look at that region, which currently the grape production ends up going into pisco production because they aren't producing a product that they think can compete on the international market as table wine. And with our team, Christian Butzka leading the enology, bringing in a viticulturist, we're able to go down there, understand their practices, work with the university to try to help them look at how technology can help them optimize their water usage so they're not applying across each block the same amount of water, understand what they should be planning, how they should change their practices, and even an economic model to help them grow to adopt new technology by forming basically a cooperative using the university's state-of-the-art facility with local growers to take their winemaking production practices from about the 1950s or 60s, according to Christian, who's in the back of the room, up to modern day practices. And so the goal is working with them to see what they want to do. Our first question, as it always is what is your goal? Is your goal to be more sustainable? Is your goal to increase the value of what you're doing? Do you want to be something that's just consumed locally, or do you want to be a player on the international market? And we've been working with them to come up with a strategy to become an international wine producing region.
And I greatly applaud that, by the way. I think more wine production is a good thing, particularly if it's sustainable.
Yes.
And so, anyway, other questions from the audience for David? Nate?
You began to mention...
Hang on one second. Nicole is going to bring you a...
Okay. Sorry. David, you began to mention about... What? Oh, you began to mention about midway through your presentation talking about the growers locally in those spaces, yet the team from Purdue applying some rather advanced computing algorithms and such to analyzing that data. Can you describe what it's been like trying to convey to growers in a local area the use of that kind of technology and what that means from maybe something as basic as a sort of a training perspective for those local growers?
Absolutely. And the thing that allowed us to understand who to start working is the fact that Christian was the extension enologist for the state of California before he joined us here at Purdue. So I had those connections. I already had some relationships with some small producers. But in doing this, when we tried to form a West Coast network of schools, we chose to go with the schools that are actively doing training for those producers. For instance, Cal Poly San Luis Obispo has a great program in irrigation training. They do all the irrigation training for Driscoll's and a lot of other people, and offer multilingual training because they found that a big impediment is that the training material, when they started doing their courses, some wrong words were used and no one could pass their certification program. And they do it where they get feedback from the locals and what the practices they actually work that are better than what's being trained to. So we've always tried to incorporate this. And I feel I'm very fortunate to have met in like 2010 a grower and producer who his family's been growing grapes and making wine since before Prohibition, and has a vineyard planted in 1938 that we've been able to work with. He knows he needs to change what he's doing. He hates using technology, but he was able to allow these geeks from Purdue to come out, instrument his field, and start working with them and trying to understand his problems and come up with a solution. And if you start that grassroots effort, what we find is word of mouth, bringing people in, as long as you don't come in and think you know what they should do better. But we're working with Cal Poly San Luis Obispo, Cal State Fresno, Oregon State and their extension team, as people who already have credibility working with growers, are trusted parts of the community, and that's really needed to get that out there.
That's great. Great question. Anybody else? I
see a hand there in the middle of the darkness.
Good.
Hi, I'm Professor David Warsinger, and I have a question which is also a bit of a selfish plug. So you mentioned that the high salinity is a major problem in the region. Are you looking at water treatment or desalination to improve the agriculture in this region?
So in Peru, that is a problem, especially from the water that's filtering down through the irrigated farmland and then being used in the river valleys. There's a lot of different things that we're looking at there. We're looking at doing water desalination. There's a lot of filtering and other processes that is going on. The first stage of what the Arequipa Nexus team is doing is trying to map out those problems right now and understand the causes and set up those experiments. So that is a very big thing. We happened to see a vineyard that was planted on Salt Creek rootstock from UC Davis, the most salt-tolerant rootstock, that was showing burn problems because it still isn't good enough for some of those regions. Other regions are fine. So it's very isolated and specific, and that is a key component, besides dealing with the other pollutants that come in the 15 to 20 miles from the source down to the irrigated valleys.
So, by the way, I don't know if you're involved with the Arequipa Nexus project, but certainly if you have interest in that, Victor Maque is sitting there. Victor, raise your hand. And Tim Philly couldn't be here this afternoon, but But by all means, follow up with them, and we can learn more about, how water desal and the things going on in Peru right now could come together. Anything else? I see a hand over there. Yes, Ali.
You spoke to having a shortage of skilled labor in the U.S. agriculture. That's especially prevalent here in the Midwest. I can speak to it firsthand from our family farm. What is the impact you see on automation is reducing that skilled labor shortage and allowing for more throughput?
That's really a good question that we've been trying to understand from growers. Thing that you find with perennial crop, Jerry Lohr owns J. Lohr Winery. He's now endowing a bunch of engineering departments and buildings across the U.S. to introduce precision ag into perennial crops, because his wheat farm back in South Dakota is, he said, 30 years ahead of what he sees in his vineyards. And so we had a really good discussion when he hosted a workshop for us about the fact of what are we going to need in the skill set as we get mechanization in there. How do we train these people to go in and run the mechanical pruners and to do all of these things? And there's a real concern that they won't, that while, crops are being left in the field sometimes, especially with changes of new legalized industries that are harvesting around the same time in California, that they can't get crews to pick their crops. They actually are worried even more about getting people who can operate this automated equipment and do it correctly. So I think training is a key component. So while they were thinking that could really solve some of the problems, there was a real hesitation of we may be getting into a bigger pit than we're currently in now. Molly? Yes.
I have a question about what you mentioned about deep learning, and a lot of has been very successful. You need good training sets.
Right.
I don't think with all the advances we have in supercomputing, we could predict the weather in the next season or next year anytime soon. Are there examples of cases that you have found where you could apply deep learning to something useful in the decision making?
Sure, we have some examples where we've been using deep learning on some trained data sets that are a good representative of what's going on. They've worked very effectively in doing social media analytics, for instance, for situational awareness in large-scale disasters. In the agricultural space, what we've been doing is trying to bring the human in new environments and to do interactive training. There's a group that sort of came out of more the human-computer interaction visualization community that have been doing this idea of interactive machine learning for about the past 4 or 5 years. And I've been collaborating closely with those people because it's a way for you to quickly provide feedback and do it to any type of analytical algorithm. Improve your clustering algorithms, because humans are much quicker. If you put a number of dots on the screen, they can find the clusters more accurately than what the state-of-the-art computer algorithms are. So how do you bring that expertise in? So we're working with incorporating those type of techniques, as well as bringing in these statistically based predictive models. For the weather, there's a company called Weather Trends 360 that does a forecast 11 months into the future. Every day they do the day 11 months from today. And it's all done with a data mining approach, looking at historical data records. And it turns out for the Midwest that their accuracy in growing degree days is within a couple of %, and weekly rainfall is also within 5%. So they're very accurate for that. The coastal environments are a little more of a challenge, but we've found that using their forecast 8 weeks into the future actually has allowed us to predict harvest very accurately in unexpected growing condition years. So, and when we did the analysis, we did an analysis because they won't give you any historical data to check them out. So we did an analysis over a year of looking at infield data and what they predicted. And when I looked at the graphs of the data, I thought there were cases where they didn't get the highs right and they were too low. But when you looked over the entire growing season, they were within 4%. And that's pretty good accuracy for this. So our goal is to incorporate all of these types of things into the future. And if you have multiple models that a human can understand, they can choose which they rely on. Because every grower I know has there's 10 weather sources they could use, but there's the one that they think is right for their field, right? And so how can you bring that in?
Okay, one final question, please. Yes, absolutely.
Thank you. Well, about the automation, I feel very close of that because I'm agricultural engineering, and I've installed several irrigation systems. I'm from Colombia, and it was a successful experience. I've been working with all kind of crops, and yeah, the automation brings the need of technical people at charge, but as you said, with a good learning process, it's very successful. And about the integration, that's a huge problem because, for example, I installed some PLC from Spain. They were very useful, but you can't share the information. Yeah, you keep the information of that farm, and I feel that if we can share the information between the farms, and not only about the yield production, the water amount, the nutrients, but the different crops. I mean, that's the huge goal of all this, is to integrate, because there is a lot of data.
There is, and I completely agree. And what I found is the grower community wants to help their neighbor as long as they don't think they're giving away something unique or a secret for them to be successful. So I'm told with corn, no one will tell you the bushels per acre that they got. The way that your irrigation strategy in vineyards seems to be the secret sauce of some growers, and they won't share. But any pest problems or the total amount of usage or the things that they're experiencing, they're more than happy to share. And the approach that we've taken with that is, can we use their data collectively to improve algorithms and share things at a level that's anonymous and helpful to the entire community. And we've done that previously with healthcare data to make sure that you can't identify who the grower is, because in different regions, if you're talking pork production in some states, you know it's going to be this producer, right? So you need to have aggregation at a scale that is anonymized. And I think that's very important. And I just talked to a large-scale company recently who decided to go with an automated irrigation system, just automated valve controls, because it will reduce labor. And they've got one person who will be responsible for turning on the valves across all of their properties every day. And that person's already there, so they felt comfortable doing it. The company has all kind of advanced data products to help them decide what to irrigate. They're not going to do that. They just wanted to reduce the number of people going out physically and turning valves on and off because they didn't have that labor. So it does offer chances, but other types of advances, the more futuristic and the more complicated the advances, the more concern people have in, are they going to be able to train people? And you don't have young people going into farm working now. The average age of the farm worker has increased by over 5 years. So these are people who aren't as physically adept as they were, and also aren't as exposed to technology as the new generation of people that you would expect going in.
Thank you so much.
Thank you.